All right, good afternoon. It's good to see everybody. I hope you had yourself a good weekend. As of right now, we have 3 weeks left. There's a few things we need to take care of between now and, of course, the 27th. But our plan for today is I passed back your papers. What we're going to go ahead and do is kind of pretend that's a practice run. The grades weren't as high as I think we would have liked, so I think there's a little misconceptions, maybe a little bit of difficulty going on. So we're just going to go ahead and talk through that exit ticket together. Any questions you may have. Then what we're going to go ahead and do tomorrow when we come in, I put together a brand new exit ticket that looks very similar to this one. I'll just take the higher of the two grades. Now you can still retake, but tomorrow that's not a retake. I'll take it all the way up to 100 if you make it. Okay. All right. So yes, if you're not here, then we'll have to take it the next time you are here. Unfortunately, we're still in testing season, so Friday, wow, okay. Wednesday if you're here, yeah. Now, a few other things that are going to be happening, if you've had the opportunity to take a look at the website, Thursday we have our second exam of the grading period. It's going to cover series and sequences. So I'm already going to let you know ahead of time, bring all your notes, anything you have, you can use those, okay. Now, next week on Wednesday, everybody's favorite, guess what's happening? The district assessment. Next Wednesday is the final district assessment. So we have several more grades that are going into this grading period. And before the 27th, I need to talk to you about parametric equations and polar coordinates. Those are two topics that Mr. Heinrich definitely asked that I go ahead and cover before the school year is out. So we definitely have time to do it. It's going to be a little constricted, but we'll be able to make it. Yes? Okay, yeah, so like this right here, we're going to go over the whole thing together. Yeah, we're going to get it taken care of. So what you're telling me is you missed Mr. Gonzalez, right? Okay. We liked Mr. Gonzalez, right? Okay, okay. He's developing into a good teacher. Okay, okay. All right, good, good, good. Actually, I was not planning on doing that. But here's the thing. I mean, if you found them to be easy grades, I could put one together. Let me ask the other classes and see what they think. It'd probably be based on what we're currently doing. So like this? Alexia says no. Well, parametric equations in a nutshell, typically all of your functions, you have y and x. Y always depends on x, but what if you wanted each of those variables to depend on a separate third variable that we call the parameter? That's what we're going to be talking about. But it usually sounds worse than it really is, but we'll get to it. We'll get to it. Okay, so for the brand new exit ticket tomorrow, you can still use any of your notes or, whenever you go ahead and take it if you're still taking one of the AP exams. You can bring any of your notes. That includes the review that Mr. Gonzalez talked to you about last Monday. This right here, the exit ticket from last week, can be used as a review if you've worked any problems off of the assignment or even just the notes that Mr. Gonzalez talked with you during this concept. Oh, absolutely, absolutely, absolutely. Now, just like before, I am also going to go ahead and provide you on tomorrow's exit ticket all of the formulas, just like this right here. Okay, so if you're dealing with an arithmetic series, then there are two different formulas you can look at. And depending on the formula you use, well, that's going to need a different set of values or variables, but we'll get into that. If it's a geometric series, you have one formula. If you're adding a specific number, you only use this formula down here at the bottom if it's a infinite geometric series. And we'll talk about that in just a little bit. But let's just go ahead and get right into it. Number one, find the 28th partial sum of 27 plus 14 plus 1 plus ... Now, this one, you're not told whether it's arithmetic or geometric, so how would I know? By the way? There you go. You're either adding or subtracting the same number over and over again, in which case would make it arithmetic, or you're multiplying by the same value over and over again, which would make it geometric. Remember, the difference between a sequence and a sequence is just an ordered progression of values. Like here, you're provided the series. So the original sequence would be 27, 14, 1, dot, dot, dot. But as soon as I start adding those terms together, that's what we call a series. Okay? So this one's definitely arithmetic. What's that common difference that we're using over and over again? Okay, what kind of 13 though? Negative 13, there we go. 27 minus 13 is 14. 14 minus 13 is 1. 1 minus 13, so I know the next term, the fourth term, would be negative 12. Okay. So we know the first term is 27. Can anybody tell me how many terms is it that I'm wanting to add up? 28. Find the 28th partial sum. Now, when it says partial sum, it's that this series continues forever, but you can't add an infinite arithmetic series. You have to add a specific number. So in this case here, we want to add the first 28 terms. So looking at all the information I have, the common difference, the first term and the number of terms, we come on back up here. Would I be using the first formula or the second? The second one is already available to me. You'll notice I do have the number of terms in. I have the first term, and I have the common difference. Now remember, it doesn't matter which formula you use. If I were to go ahead and use this formula over here, I still have the number of terms in the first term, but this last term right here, that would represent the 28th term. So I'd have to do a little bit of work in order to find that 28th term if I wanted to use that formula. But if you already have all the information you need for one of them, I'd say just make it easy on yourself. Is everybody okay with that? Okay. And that's what series really boils down to. It's just going to be formulas. Okay, so this formula here, the sum of an n number of terms equals the number of terms divided by 2 times double the first term plus the number of terms minus 1 times the common difference. Okay, but we have all the values, so we just substitute in. How many terms were we adding again? Okay, so the sum of these 28 terms is n divided by 2, 28 over 2. Times double the first term, so I'm going to double 27. See, all I'm doing is plugging in those values. Plus, then we have 28 terms minus 1. I'll go ahead and just put 27. And then we multiply that by d, negative 13. Okay. Now from here, I can immediately go straight to the calculator. If you're like me, I like to simplify it a little bit further, and make it easier on me. Like, for example, what's half of 28? So 14 times, if I double 27, 54. Now, as far as that product goes, 27 times negative 13. I'll just go ahead and let the calculator take care of it. Yes. Yeah, go for it. All right, so if I go ahead and plug this into the calculator, let's see what I get as a grand total. 14, come on over here, 14 parentheses 54. Plus parentheses 27 times negative 13. Okay. The only difference is instead of brackets, I went ahead and used parentheses for the entire expression. All right, so as soon as I push enter, if I were to take the first term and add it all the way through the 28th, I should get a grand total of negative 4,158. Okay, questions? So negative 4,158. And there we go. I got to tell you, it actually feels good to be up here teaching again instead of just sitting over to the side. But we do miss Mr. Gonzalez, right? Of course we do. Okay. Now, does anybody have any questions? Is anybody confused by number 1? Okay. Now, for number 2, there's a couple things I want to go ahead and show you. All right. So let me go ahead and erase this. Okay. So what does this symbol mean right here? That capital Greek letter sigma? Summation. That tells me in math we're about to be adding a bunch of terms together, or a bunch of values. So here's the thing. We have a lower value and we have an upper value. The lower value is the term number that I want to start with. So I want to start with the 6th term plus the 7th plus the 8th all the way to what term? The 28th. The upper value is going to be the term number that you stop at. Now, this rule right here, in this case, it's 5n minus 17. This is how you would generate the series if you wanted to see it. So, for example, let's say I want to know what the 6th term actually is. So a sub 6 equals, well, all I would do is just plug it in. So 5n minus 17, that's 5 times 6 minus 17. What's that give me? 30 minus 17, 13. So let's say I want to find the 7th term. So 5 times 7 minus 17, 35 minus 17, 18. Let's go ahead and find one more. So the 8th term would be 5 times 8 minus 17, 40 minus 17, 23. So see, this is the sequence starting from the 6th term, 13, 18, 23. What this is telling me to do is to add all of these up until I get to the 28th term. Okay. So looking at that sequence right there, well, I should say series because I put pluses. How am I moving from one term to the next? 5. So this is arithmetic, my common difference. I'm just adding 5 over and over again, right? Now that's one way, if you're given this notation, if you want to figure out what the value of D or R is, if it's geometric. But there's also another way. Let's say we hadn't created these terms here. Just look at the rule. Does that rule look familiar to anybody? What kind of function is that? Starts with an L. It's linear. See, it's in the form mx plus b. In fact, every term is increasing by 5 because that's the constant slope of that function. So you don't necessarily have to start creating the series if you recognize what function it is and go with that. Does that make more sense? Is that okay? Okay, so D is equal to 5. Now, let me go ahead and show you. We're going to use the same formula to start with here. So the sum of an n number of terms is equal to n divided by 2 times double the first term plus the number of terms minus 1 times the common difference. Now, actually, on this problem, I'm going to show you that if you use both formulas, you're still going to get the same answer. Okay, but I'm going to start with this one first because there's something I want to show you. When it says the first term, it doesn't necessarily mean the first term of the entire sequence. Like I'm not going to plug in n equals 1 and get that value. What it's referring to is the first term of the set that I'm adding. So in this case here, remember you said I wanted to start with the what? So this is actually referring to the 6th term. Okay. So the first term refers to the first term that you're adding, not necessarily the first term of the series. Is everybody okay with that? Okay, so we already have that. We know that it's 13. The only other thing I need is the number of terms that I'm adding. Can anybody help me out? Okay, now I did help you out with this. Did anybody notice that I did tell you that? So if you did notice that, fantastic. But if you didn't, how do I find the number of terms? Well, if you're given sigma notation, you want to subtract the two values. Take the upper, subtract the lower, but that's not 23. What do I have to do? I have to add 1. So you'll subtract the 2 and add 1. That's where I get the number of terms that I'm going to be adding up. Does anybody want me to elaborate on why we have to add 1? You have to include the 6th term. So when you subtract 6, you're subtracting the first term off of the set that you want to add. That's why you have to account for that with the plus 1. Everybody's okay? So we have everything we need, 23 terms. D is equal to 5, and the first term is 13. So just like before, we substitute in, and let's simplify. So the sum of these 23 terms, what is 23 divided by 2? A number, 11.5. Okay. Now, if that 6th term, the first one that I want to start with is 13, if I double that, I get 26. I'm going to add, remember we're adding 23 terms together, so 23 minus 1 will give me 22, and then times the common difference, 5. Okay. So let's plug that in the calculator, and let's see what we got here. 11.5 times 26 plus parentheses 22 times 5. Okay, so if I continued that pattern, 13 plus 18 plus 23, all the way to the 28th term, should be getting 1,564. Okay, any questions? How are we doing? Campbell, we good?
Yeah. So is n always going to be?
Yeah, so that subscript, that's the number of terms you're adding. Mm-hmm. So 1,564.
So you don't necessarily have to subtract.
Oh, well, I will tell you that I am providing that for you, even if you forget how to find it. I can't necessarily say that, like, others will provide that to you. You know? Okay, now let me go ahead and show you the other formula. Now, the other formula is a lot simpler. It's much smaller. Okay, it reads like this. The sum of those terms is going to be the number of terms divided by 2 times the sum of the first and the last here. Okay, now we have a lot of the same information. N is still 23. Okay, so we have that one. Remember, even though the formula says the first term, in this case, we're really referring to what? The sixth term. Okay. We have that. What do we not have? Oh, not the 23rd, the 28th. Remember, there are 23 terms total from the 6th to the 28th. So this A sub n right here represents the 28th term, but we don't have the 28th term. How would I find it? Just plug it in. Yeah, like if I wanted the 6th term, I plugged n equals 6 in. So if I want the 28th term, I'm going to plug in n equals 28. So 5 times n, 5 times 28, minus 17. So somebody help me out with that. 5 times 28 minus 17. 123. So see, I had to do a little bit of extra work in order to use this formula, but now I have all the information. So the sum of the 23 terms is equal to 23 divided by 2 times the first term of the set. So in this case, it's the 6th term. Remember, that was 13. And we just found the 28th term to be 123. Okay, so let's simplify this. Remember, 23 halves was 11.5. What's a 13 plus 123? 136. Now remember, what we get as an answer? 1564. So even though it's a different formula, I should still be getting the exact same number. Let's see here, 11.5, oops, times 136. Boom. Okay, so you can use either formula for an arithmetic series as long as you have the correct information. Okay. How are we doing? Is this helping? Okay. Cool. All right, well, let's take a look at number 3. Okay, find the sum of the first 6 geometric terms of the geometric series. 8 plus 14 plus 24.5. So let's say for a second that we were not told this was geometric. How would we know? Yeah, just look at the pattern. Like, let's say, for example, we thought it was arithmetic. How do I get from an 8 to a 14 through addition? I'd have to add 6, right? So, well, 14 plus 6 gave me 24.5. No, it's not constant, so this is definitely not arithmetic. Okay, so we know it's geometric, but how do I find R? How do I find, okay, we find the common ratio through division. We should be able to divide consecutive terms, but you always divide a term by the previous term. So for example, I could take the second term, 14, and divide it by the first term, 8. So that should give me 7/4, which is the 1.75 that I just heard. Now remember, if it is geometric, you should be able to take any pair of consecutive terms and get the same number. And you can check this in the calculator. 24.5 divided by 14 will also give you 1.75. Okay, so I have R. And I got a little ahead of myself. If it's a geometric series, there's only the one formula you're going to be using. S sub n equals. Hey. Oh, okay. For Avery? Oh, okay. No, the one I let you. Okay. All right. Are you not? Oh no, you're not going to be here today. How'd the test go? Okay, well, okay, cool. All right, good. Okay. So the formula was the first term times 1 minus the common ratio to the number of terms divided by 1 minus the common ratio. So we already have R. Okay, what's the first term? Okay, so a sub 1 is equal to 8. What's the number of terms that I'm wanting to add? 6. So this one, we didn't have to do any extra work. We were able to easily find all of our values. Now just plug them in. So S of the 6 terms equals the first term 8 times 1 minus the common ratio 1.75 raised to the 6th power divided by 1 minus the common ratio. There we go. Okay, just taking those values and plugging them directly into the formula, and now we turn to the calculator. Okay, so let's see here. We have 8 parentheses, control divide, 1 minus 1.75 to the power of 6, divided by 1 minus 1.75. So somebody help me out. What should I get when I push in? 295.71. Perfect. All right. Questions? Okay, we ready to try one on our own? Okay, absolutely. All right. And what's the only difference between numbers 3 and 4? They're both geometric. Yeah, they're just different forms. So number 4, you are given this sigma notation again. Okay, you're still going to be using this same formula right here. Let me go ahead and take off the previous one. So you only need to find 3 things. You need to find the common ratio R. You need to find, now in this case, the first term you're looking for is actually the what? What's that, Campbell? What's the first term I need to start with? The 16th. Okay. And then you have to find the number of terms that you're adding. Okay. Remember, when you're given sigma notation, the lower value is the term number you start with. The upper value is the term number you're finishing with. And there was a typo on here. There should be a parentheses, but that's okay. Hey. Okay. Now, we'll tell you on this one, you should be getting a somewhat big number. Okay. So some people actually told me last week that they didn't think you could get a number like that for these, and that's perfectly fine. I'll go ahead and tell you it's in the billions. It's going to be a big number. Why make trillions when we could make billions? You guys have seen Austin Powers, right? Because I did that joke earlier and nobody knew what I was talking about. Yeah, Vern Troyer. Why are you giggling? Oh my God. Wow. Oh my gosh. Usually I'll go ahead and have that written, like on number 3 right there. Mm-hmm. Mm-hmm. In this case, n equals 16, yes. Okay, so I'll go ahead and write that down. We're going to take the upper minus the lower, but then plus 1. That's a good question. Would you like me to help you out or go ahead? It is 2. If you go ahead and take a look, the formula that they're providing here is the nth term formula for a geometric sequence. You remember several weeks ago, but Mr. Gonzalez was telling you that the nth term is the first term times the common ratio to the n minus 1. So if you compare what we have here to the formula, yeah, you can see immediately that the common ratio has to be 2. Now, another way you could have done that, you could have started, with, let's say, n equals 1, n equals 2. You could have generated the series like we did on a previous problem and then look to see what the pattern is. Okay. So there are several different ways, but that's good. So since our time together is rapidly coming to an end, does anybody know what type of shoes a frog would wear? What type of shoes would a frog wear?
Hold on.
Open-toed.
Okay.
I was gonna go with Crocs.
Open-toed? Like a toad frog? Yeah. I got to get as many in as I can because, we're about to be done. All right. And can anybody tell me what the 16th term is? Well, that's not the 1 billion number. Okay, so how would I find the 16th term?
I have no idea.
What am I going to replace n with?
Oh.
16. Okay. So this would be 1/2 times 2, but 16 minus 1, that would give me to the 15th power. So if you did go ahead and plug that in the calculator, you should be getting 16,384. Or I could plug it in the calculator and show you that. Would anybody like me to plug that in? Okay. So you'll notice now that I have these 3 values, I have everything I need to find the sum of those 16 terms. Okay. So the sum of the 16 equals, well, the first term, remember the first term of the set that you're adding, the 16th term was 16,384 times 1 minus the common ratio 2 to the 16th power divided by 1 minus 2. Again, all of this comes down to a formula. You just plug in the values that you find. Okay, and let's see the number that we should get. So 16,384 parentheses. Ooh, wrong button. Sorry. Control divide. That was 1 minus 2 to the power of 16. And then 1 minus 2 is just -1, so I'll simplify that portion. Okay, so here's what you should get. 1,073,725,440. 0, there you go. Okay, how many people got that? Okay, so what can I do to help? Was it finding one of the individual pieces, like the common ratio or something?
No, I just decided to stop early with the 16th term was
Oh.
negative.
Okay.
I don't know why.
Okay.
So will A sub n be the same as A sub 1 and all of these?
Yeah, so it depends what value you plug in there. So A sub n can represent any term. Typically, we call it the nth term. But once you start plugging in for n, like A sub 1, that's the first term. A sub 10, that's the what? That's the 10th term. Yeah, and so forth. Okay. The only difference with the notation, if you're using S, so while this is telling you what term it is, this is telling you the sum of 10 terms. Oh, this is sigma notation.
So if it's sigma notation, then these probably do at least not is a to the like a sub n, like a sub 16.
Uh-huh.
That's going to be the same as a sub 1,
For the formula, yes.
right? Right.
Because for the formula, while it's referring to the first term, it's the first term of the set you're adding. Yes. Okay, how are we doing? Any other questions? Some of this making sense? Some of this making sense? Come on, you didn't get that with Mr. Gonzalez.
Oh, I get it.
Some. There you go. Okay. Moving on. Okay, number 5, final problem. A toddler is on a swing at the playground and his mother pulls him back so that the swing can start. He travels 16 feet on the first swing forward. On each successive swing, regardless of going forward or backward, the toddler travels 90% of the distance of the previous swing. If his mother does not push him again, what's the total distance that the toddler swings before coming to rest? So let's kind of see if we can visualize this problem. So the mother's going to pull the toddler back. She's going to let him go. Whee! Okay. How far has he gone? So he's gone 16 feet. So that's the first term, right? So we're wanting to find the total distance. Now, what we're told is that regardless of direction, every time he swings forward or backwards, it's only 90% of the previous swing. So 16 times 0.9, that's 14.4. So then he swings forward again. 90% of 14.4, that's 12.96. Remember, this is series, so we're wanting to add these up. So just take a look at my visual. 90% of the previous, over and over and over again. Okay. Think about one word that we really, really tried to emphasize in these past lessons. Starts with a C. What is this appearing to do? It is converging. It's converging to a specific value. Now, what kind of geometric series is this? It's an infinite geometric series, yes. So I'm going to be able to use this formula right here. The infinite sum is the first term divided by 1 minus r if the absolute value of that common ratio is less than what? 1. Well, is that true? What is my common ratio? 0.9, or if you want to say 9/10, that's fine. So 0.9 is definitely less than 1, so I can absolutely use this formula. Well, 16, the first swing, well, that's the very first term, and we already know what r is. Okay. So it's just a matter of plugging in. So the infinite sum equals, the first swing was 16 divided by 1 minus 0.9. What's a 1 minus 0.9? 0.1. And what's 16 divided by 0.1? 160. Okay. How are we doing?
If it's not, what do you mean?
Then that would mean it diverges. You can't find the infinite sum. Now, you could probably go ahead and find yourself a partial sum, like on the previous ones if you wanted to add maybe the first to the 12th or whatever. But unless this rule is satisfied, you can't find the infinite geometric sum. And one other thing, you can never find an infinite sum if it's arithmetic, only if it's geometric.
Why?
Well, because think about it, whether it increases or decreases, you're constantly adding to the previous value. So your sum is just going to continue to get larger and larger. The reason this works is because with a smaller value, basically this is a decay problem, you are adding infinitely more values, but as you continue to add them, the values themselves are becoming infinitely smaller. That doesn't work that way with arithmetic. Yeah, because you're actually not the first person to say that. So if you add all the terms of an infinite arithmetic sequence, someone says, well, why couldn't you just say the answer is infinity? Because technically it would be true, but the problem is infinity isn't a specific number.
It's
It's
a concept.
a concept. It's an idea. Yeah. All right. How are we doing?
Yeah, it's the equivalent of saying the answer is a number.
Good?
You said taking it tomorrow.
Yes.
You know, does anyone know?
Well, I already know that several people are going to be gone, so we'll have to. I mean, we're unfortunately at the point in the year where we got to keep going.
Right,
So I mean, I'll just catch people up when we get back.
yeah, I was just wondering if
Yeah.
anybody knew what.
How many people are not going to be here tomorrow? That's not terrible. So let me go ahead and do this. If you're not going to be here tomorrow, let me go ahead and give you this. I want to go ahead and get you a copy of the parametric equations. Raise your hands again. How come there's way more people raising their hands now than before? My goodness. So basically everybody? Oh my.
Because of the AP English, yeah.
AP English is tomorrow?
Yeah, AP language.
So let's do this. How many people will for certain be here? Oh my God. Oh, you gotta love testing season. Yes. hmm I'm actually just kind of planning on Friday being the catch-up day. Yeah. Maybe. Now, you're always given the full period for an exam. For the exit ticket, I was thinking 20 minutes. So if that turns out to be the case, yeah. Oh, yes, please. Sorry. All right. All right. Well, let me go ahead and stop recording. Whoa.